Ladies and gentlemen, it's Mr. Potvin here trying to record topic 4.3 image storage and transmission for the second time. We'll see how it goes. Last time we did this, it was really glitchy. So first off, we're going to start with some beautiful photographs on the side here. I'm sure you guys have seen things like this before. Take a look at the photograph if you take a look at the photograph on the left here, it's all blurry and fuzzy and things like that. And over here, it's all nice and beautiful, okay? Traditionally, photographs, you think of photographs, it's a great way to store images or save images forever, but does it really last forever? I personally love looking at photo albums, going through old photo albums. Those are like a thing of the past now because everything's kept on our cameras. But yeah, in the past, you would have things like this. I mentioned before about film and how pictures are developed, and those are done using chemicals. So back when I was in school, part of our industrial arts or shop class was taking photos. So we used something called film, very similar to what we were talking about with the eyeball there, and we would go and we'd develop our own pictures. And in order to do that, we needed complete darkness and we needed chemicals. Okay. However, over time, those photos would eventually start to fade, just like this one on the left here. Okay. Nowadays, most information is stored digitally, like our cameras, our cell phones, things like that. So what digital is when you take a bunch of information and you convert it to numbers. And it sort of makes sense in the name digitally because digits, they're numbers. So yeah, digits and numbers. This is how a computer stores information and images. Anything that it stores it as numbers. Some of you may have seen stadium images before. Some of you may have participated in stadium images before. Stadium images are something like here on the right, where a soccer game or some sporting event, a whole bunch of people found colored cards underneath their seat. And at a certain time of the game, they were all asked to hold their images up over their heads, and a drone or a camera from up above would go and snap a photo. We did this at OLQP a few years ago when we did that peace symbol. We all went outside and we all had to stand in a certain area and we made the peace symbol. We also did it at OLQP in the library. Some of you might remember a really nice picture with the OLQP symbol that one of the teachers put a whole bunch of tiny little squares together that were all painted different colors by the students and to make that symbol. Good Shepherd has also done something like this with their mosaics for their that are in their den area there from their photos, from the students' photos. From far away, you see the large image, but up close, it's just individual cards. Now, if we were to take this person, if this one was to go and switch cards with that person over there, you'd obviously see a big difference. You'd be able to see the white over here, the green here, and it would not work out. To make these cards form an image, each card must be in a specific area and address based on the row number and seat number. This is the exact same thing how digital cameras create images. More digital imaging here. You see some beautiful GIFs on the side, and they are all, what's this word? Okay. Digital imaging is the process of creating images using a computer. We can see all created by a computer. It is similar to the state images that were on the previous picture. If we go and take some of these colors and or these little squares and put them somewhere else, obviously the picture will not turn out. Okay, and when a computer receives an image, it divides the picture into small elements called pixels. And a pixel stands for pixel element. I need to know this quiz or something sometime in the future. I don't know. Okay, so it's an individual element of a digital image. We've all heard of pixels before. Each pixel is assigned a coordinate at a certain spot, just like the stadium seats, and the computer recognizes this image as a series of different numbers, which can then be stored and saved, etc. Okay? If someone wants to recreate this image, the computer recreates the coordinates and puts each pixel in its place. So they take all these colored squares, throw them all into one container, and then they put them all back into the proper order, and you get these beautiful images. Coloring an image is done very similarly. Okay, getting an individual pixel in the right order is only half the battle. You also have to make sure that the colors are correct. So the computer assigns a value to each color. When the picture is assembled, the computer reads the values of each pixel, and that's how we get that particular color. So here's a black and white image. All that's assigned are shades of gray black, white, those types of things. So here's a picture out of our textbook, and we've got a bunch of different pictures, and it's kind of hard to tell what they are. You can tell this one right here, it's pretty clear, it's somebody skiing. This one looks like a bunch of fruit on a table. This is a flower. I have no idea what type of flower it is, but this is the one that usually causes some grief. So we ask which is the best quality, which is the worst quality. Typically, this is the one that's voted as the best quality, and this is typically voted as the worst quality. Okay, and it all has to do with the number of pixels. Okay, you can see pixels in all of these. However, this one you can see the most squares. So you can see the squares, the most pixels are quite large. It's very interesting from the back of the class compared to students that are sitting close to the window or the TV at the front of the class. The pictures actually get clearer. That's kind of interesting. Think about why that happens, why farther away the pictures are a little bit clearer than when you're really, really close. Typically, students in the front of the class say this is a dog or possibly a sheep or a goat. From the back of the class, this one's typically, the consensus is the little sheep running through a field. So digital image quality. The quality of a digital image depends on the size of the pixels that make up the image. So right here, we have something called low res. Here's something that's high res. You can clearly see the difference. It's a nice fluffy sheep. This one, still the same sheep, but the pixels are a lot larger, so it's low resolution. If the pixel size is large, then you'll notice that the image is made up of small squares and you won't be able to see much detail in the image. Like this one here, you can see the little squares. This one, you can't really see the squares. The two images are the exact same. If the two images are exact same size, like these are, the one with more pixels will look better. We see this on our TVs, right? TVs having better quality over time, especially since they've gone digital. So, you know, there's the 720, the 1080, the 4K, et cetera, et cetera. That all refers to the number of pixels. The poorer the quality of the digital image has a lower resolution. The resolution of an image refers to the number of pixels per square per unit area. So the number of pixels in this area compared to the number of pixels in this area. The one that has more pixels, obviously the better the resolution. So the greater number of pixels in an area, the higher the resolution. All right, so capturing digital images. We talked about this earlier with the CCDs. Scanners, digital video recorders, digital cameras all use roughly the same method of capturing images. Like regular cameras, the light enters through the aperture, like right here or on your cell phone, and falls onto a light-sensitive area in the back. In the old-fashioned cameras, that light-sensitive area was the retina. In the old-fashioned cameras, the light-sensitive area is the film. In our eyeballs, it's the retina. In digital cameras, it is a charge-coupled device. A charge-coupled device is a device that converts the light into electrical energy. It's a grid similar to a piece of grid paper. The grid's on graph paper. But as the light falls on the squares of the grid, it creates a small amount of electricity in that square. The electrical charge is then converted into digital information. So each of these little squares over this basset hound is converted into digital energy that is given a number. Once the image is converted into these numbers, digital information can then be stored and shared, etc., etc. Oops. Transmitting digital images can then be transmitted around the world. So if you ever watch the weather on TV, right, and we go and show satellite images like these down here, you wonder how they get it. They're taken by satellites way, 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 way up in the sky, right? In order to get those pictures down, just simply develop the pictures, they have to send them. So that information is sent down to us, and our computers put all that information digitally in order so we get these beautiful pictures on site here. Okay, the satellites have digital cameras which capture the images, turn them into information, and then they can beam them into computers on Earth. So when you hear beaming, you're thinking of Star Trek and Star Wars and things like that, where they're actually taking us, little particles of us, and sending it from one point to another. Well, that's not a reality, but it is a reality for sending information. It's just digital information that they can put back together once it's back down on Earth. Okay, so the computers take all this information, reassemble it into pictures, and voila, we get them. Okay. Some digital images can capture other wavelengths. So you might have seen infrared scanner or infrared radiation, which is used to gather large amounts of heat. Gathers heat, so detects heat versus cool areas, and that actually really helps us determine things on a planet. And you can see down here, the red typically refers to like heat or something like that. That is it. Okay, so boys and girls, that is a wrap up topic. That's a wrap up for topic C, Unit C, light and optics. For assessments, we had 3 quizzes. There's going to be another quiz for this section. We had 2 labs, and we had a Flipgrid, and we had a light up your life assignment. And then, of course, there was the application questions and that first Flipgrid assignment, which was not for marks. So if you have any questions, please send me an email, and we can go from there. Thank you very much, and have a great day.